Okay, so today is completing the square again, except this time it'll look like this. What's different? What's different than yesterday? Harder than yesterday? What do you see? There's a 4 in front. That 4 is the part that's new. All right? I actually think it'd be best for us to start with a normal one. Okay, so everybody find a way to add some space. I would add a page. You don't need graph paper or anything. Let's just do a normal one that doesn't have a 4 in front. What if it just x squared plus 6x plus 1? Do you remember how we took that 1 and we moved it over? And then we did half and square. Half of 6, 3. 3 squared, 9. Plus 9, and if I do a plus 9, to keep this balanced, I have to put in a minus 9. I know that seems weird, but remember, we're trying to avoid having to add 9 to both sides. So we add 9 and then subtract 9 right away. All right, now why did I do that? Because that was the perfect number to make what's called a perfect square. All right, you sick? Yes. Okay, good. Then tell me what you think this comes out to. After I factor that, I get what? And then squared. Very good. And those two together make minus 8. Raise your hand if you followed that. Okay, good. Let's just do one where you do it from start to finish without me. So y equals x squared minus, notice I'm putting in a minus, 8x plus 1. And it won't factor. So right away, you just move that 1 over and see if you can do it. Notice there's a minus in there. I'm going to pause while I give that a try. All right, hopefully you knew to do half n squared. Half of negative 8 or negative 4 is squared, and then negative 4 squared is positive 16. Raise your hand if you knew there was a positive 16 right there. Good. And then don't forget the negative 16. And then this part here can be factored into x minus 4. Did you remember the minus? Everybody puts a plus there. All right. I mean, when people make a mistake, that's one of them. And then people forget the squared a lot of times. And then lastly, we have negative 17. Cool. Now, one more thing we're going to add today is knowing what this really looks like. So what's its vertex? That's not too tough. What's the vertex? 4, negative 17. And if I were to graph it, do you know where 4, negative 17 is? Basically way down there. Does this one have a negative on it in the front, and therefore is it flipped? No, it's not flipped, and therefore it goes something like this. So now I kind of know how it looks. Once you got the sketch, then you're going to have to tell its domain and range. Does that ring a bell? We want those to not fly out of your head. We need those to stay. Domain is left, right. So how far does it go this way and this way? It'll go forever if you extend it up far enough. Negative infinity to positive infinity. And then the range, that's from low to high. Even just last hour, I had somebody who had that backwards. Happens all the time. If this spot is really 4, comma, negative 17, which of those two numbers matters in the range? The negative 17. So it's negative 17 to infinity, because it goes how low to how high. All right, and does it touch the negative 17? Yes, it does, so put a bracket on it. I know some kids are just getting by for now thinking that every infinity gets a parenthesis and every regular number gets a bracket. That may have been working for you for now, but when you do the ones with asymptotes, it won't. That's why I keep saying, does it touch negative 17? And it does, so it gets a bracket. Because when we do the asymptote kind, when it's getting close to it but not touching it, it'll get a parenthesis. All right, so that pretty much covers the old stuff, and now watch me do this first one. Okay, you need to learn how to do it. You can't just jump in and do it yourself. This one's a little bit, it's going to add another tool you never knew you could do before. Remember me asking, like, can you factor it? If you can factor it, you should, right? But this one, you can factor even though it looks like you can't. What seems like it's foiling the factoring is the 17, because nothing goes into 17 except 17. So how could I factor it? I just set the 17 aside like I did before, and I just factor this part. I take the 4 out, and I have x squared plus 4x. Now I can keep going, and do you get how I have a stretch factor on this one? You see the stretch factors out front? This is how you're going to do the kind that have a stretch factor. Okay, now I still have my plus 17 down here, and it didn't have the 4 factored out of it. Now I can do it just like all the other ones, with one little exception. First you do half of the square like normal. Half of 4 is 2, 2 squared is 4, plus 4 and a minus 4. Now what, somebody noticed this last hour, I was impressed. What do you think is wrong with it as it is? I have broken a rule. Let's see if anybody can catch it. I was really surprised that somebody caught it last hour. Maybe somebody. What do you think?
You didn't do it on the Y too?
Okay, so what do you mean do what on the Y?
You didn't, wait, never mind.
Okay, what do you think? So something about this 4 here? Is that what you're saying? There is something related to that 4. So what I'm asking is, what do I need to do different to make this equation right? What do you think? Yes, good catch. These are supposed to cancel each other, right? Well, this one's going to get times by 4, and all of a sudden it's not going to be canceling the other one. So this has to be times by 4 so that that can be negative 16. Nice job. So here's the moral of the story. This 4 is going to times by this, so we need it to also times by this. That little times by 4 there, I'm going to keep reminding you because that's the most common mistake on this next test, is people forget that. We need those red 4s to cancel each other, and this one's getting scaled up by a factor of 4, so that one needs to get scaled up by a factor of 4. Yes? Everything I've been doing to the one side only, because really all I did is factor out a 4. That doesn't require me to factor anything out on this side. Because really what was done was this got factored. That doesn't force this side to get factored. You can just factor one side. That's legal. But the fact that it got factored and that made this 4 bigger makes me make that 4 bigger to compensate for it. Okay, so many little chicken scratchings there. I'm going to clean this up. There was the point where she noticed that that had to be multiplied by 4 so that this 16 will get canceled by that 16. Okay, so here's my final answer. 4x plus 2 squared. And now it's negative 16 plus 17 down here on the end in this little zone. That's where I get negative 16 plus 17, and that gives me plus 1. There's my equation. You get it's got a vertex of negative 2 comma 1, and this time it's got a scale factor. What's the last thing that we sometimes have that we haven't dealt with? We sometimes have a scale factor, and we sometimes have a negative, a flip. What if that was negative? All right, so here's something like that. First of all, I got to make sure you get how to factor a negative out of something. Even my honors pre-calc kids had trouble with this. Can you factor a negative 1 out of that? I bet you 5 of you can. Properly factor out a negative 1. Raise your hand if you know it. I was thinking there'd be 5. Come on, be one of the brave 5. AL, what do you think? There's about 4 hands. I was close. Negative 1. You got it. That's it. If you take a negative 1 out, they both become the opposites. All right. Now you might be thinking, why would you ever do that? When the problem has a negative on the front of it, and I don't want it to be there. Let's say this was my problem. I would start by saying, okay, let's get the -1 stretch factor out of it. -1 comes out, and then I make it positive x squared minus 6x. Notice, when you factor a -1 out, you can't just slap a -1 in front. You got to change this to the opposite of itself. It's turned into positive. And that to the opposite. It's turned into negative. Another way to check if you did it right is you can go this times this. That makes -x squared, just like it's supposed to. And this times this makes positive 6x, just like it's supposed to. All right, with that preface, now take a look at this problem. Problem number 2. What's its issue? Do we need to factor out a number? Nope. We need to factor out a negative. You could argue it's a number. You could argue that we need to factor out -1. But remember, the 94 doesn't get touched. We move it over here and we don't mess with it. I know you could factor out a negative from that, but it would just mess you up. Don't do it. X squared minus 20x. Raise your hand if you did that right. Awesome. Notice that both of them changed signs. It went from -x squared to positive x squared, and from positive 20x to -20x. Now, I can do my half and squared thing, and it's all going to be just like the other kind. Yes? Always move that over first. That is step number 1 on every single problem. Second step, if there's anything here, factor it out, because that's got to be your stretch factor that goes in front. Step number 3, half and square. What's half of 20? Technically it's -10, but since I'm going to square it anyway, it doesn't really matter. So it's positive, what? 100. If that's plus 100, then it gets counteracted with a -100. And then I'm bringing my minus 94 down here. And I just did something wrong. What did I forget? This would make -100, so what do I have to do here? It needs to be positive 100. I'm going to say it this way. This -1 has to be also multiplied right here, and that will make that positive 100. You're exactly right. That's the most missed step. Second most missed step is people forget about that minus sign right there. So your final answer, -1, parentheses, x minus 10 squared, and positive 100 and -94 makes positive 6. Next. Seems like we should be able to be done, but you're in honors, so we stretch you. Answer all 1, 2, 3, 4, 5 questions there that are in green at the bottom of the page. Hint, I strongly recommend a sketch. When I grade these tests, a lot of times I'm going through and a kid will get it wrong and I'll go, I wonder if they made a sketch. And I'll look and they didn't make a sketch. And then they get it wrong. Sound familiar? I'm looking at you. And there's many other people who didn't make a sketch on the last test and then made a mistake. Take a second, make a sketch. You know what this thing looks like. It's an upside down parabola that has a vertex. And if you put it in the right spot and you make a little sketch, especially the range, I don't even think I can do it without a sketch on the range. I need a sketch. If nothing else, I'll sketch it in my head and then figure out the answer to the range. So sketching is a very powerful little tool. I'll pause for a second while you give that one a try. See if you can answer the 5 green questions there at the bottom. Okay, let's see if you got vertex form. Well, that was already here. Vertex 10, 6. Still some people think it's -10. If I go to 10, 6, that's like here-ish. And then I'm going to go, is it right side up or upside down? That negative means it's upside down, and that makes a big difference in, especially the range, because the domain actually wouldn't matter. It totally matters on max or min. It now has a max, pretty obviously. It's got a high spot right there. The domain of it is all reals. I would like to write that as negative infinity to positive infinity, because it goes forever in both these directions. If you extend this graph out, it'll go forever that way. And lastly is range. Will it go forever in both of these directions? No. That point right there has a 10 and a 6 in it. Which one is important in this case for range? 6. So it goes from negative infinity to 6. Now, I get it all the time. People say, but I think you should say it from 6 to negative infinity because it's going down. But here's the thing. The ranges always have to be in fact, all intervals for the rest of your life when you write an interval, the smaller number has to be first. So you can't say 6 to negative infinity, even though it might make sense in your head. You have to put the smaller number first, and negative infinity is the smallest number that there is. Yes? Ooh, I think somebody got me. It touches at 6, so there should be a bracket on the 6. Now, what if everything was right on your test except that one thing? I still have to note it. If there's something wrong at all, the minimum deduction I can do is 5%, and that's probably what I'd do in that case, because you got so many things right, and I just lost 5%. So if it was my only mistake, it wouldn't count at all. You know what I mean? Because you get one free mistake. But if this is your second mistake, having a bracket could cost you. I mean, you just saw it happen to me. So be careful. A few things I would check at the end with it. I would make sure my equations has y equals on them, and I would always make sure that I didn't screw up a bracket. That's my most common mistakes, and occasionally negatives. All right, one last one to seal it off. If you can do this from start to finish with no hints from me, then you are totally ready. And if not, I'll show you what you did wrong. I'll pause for a second while we work on this. Here we go. 3 comes out. X squared minus 8. And I hope you didn't try to take a 3 out of 40. We purposely make that number so you can't take a number out of it by accident, but we don't promise to do that forever. If that had been like a 33, you would not have wanted to take the 3 out of it. You would have wanted to just move it over like this. There, the plus 40 is over at the end. Now I put in my parentheses and I do half n square. Oh, I forgot an x. Half n squared, half of negative 8 is 4. 4 squared is 16 plus 16 minus 16. And then I have a y equals 3. X minus 4 squared. Those go together. I make sure nothing got factored out. Oh, something did get factored out. So there's a 3 in front. So that means this has to be times by 3. How many of you caught that? Raise your hand if you did. Awesome. The most missed thing by far. Then that 16 times 3 makes 30, 48. Negative 48 plus a 40 makes a negative 8. And I'm going to double check it because I know I should, because these are tricky. And I think I would have put this on my test. Do you guys agree? All right, cool. Then, what's vertex of it? 4 comma negative 8. Easy peasy. Max or min? Well, I better make a sketch here first. So I'm going to go to 4 comma negative 8. That's down here. And there's no negative in it, so it's probably a right side up one. And so then, now I can answer that. It's got a minimum. The domain of it is all reals, so negative infinity to positive infinity, because domains for parabolas like this always go forever like that. And last thing is the range. Which of these 2 points matters, the 4 or the negative 8? Negative 8 bracket to negative infinity. Most common mistake right there. Yeah, I know. I said most common mistake right there is screw up the range. So then what does it go from? What's the lowest? Negative 8. What's the highest? Positive infinity. The range will be the tricky one. Not all of those. I'll mark the range wrong more than anything else. Okay, there you go. Now, one more little life improvement for you. I checked in to this with my colleagues, and they're okay with me trying this. I'm going to make the Schoology quizzes give you the answers after your first try. Okay, so you give it a try and you hit, submit. It's going to say this was wrong and this was wrong, but it's going to tell you the answers immediately. Instead of you having to walk up and go, Mr. Server, I don't get what I'm doing wrong on this one. I think it's right. it'll tell you what the right answer was. And then you'll know if it's just me typing it in wrong, fine, and I'm not worried about it. But if it's you doing it wrong, you'll know. Could this be abused?
Yeah.
Absolutely. But, excuse me, but I know that there are some of you who are going to use it well and be able to look at those answers and therefore get a lot of good information out of those answers. And there'll be other kids who are going to abuse it by going, I get it all wrong, I can see all the answers, and then I can just do it again and get a perfect score on it, and I don't even have to learn anything. Do you get what I'm saying? They won't learn anything. They're just going to be copying stuff over. Yes, but you know what? That happens on our other worksheets too. The other worksheets that have the keys. You know what I mean? That opportunity to kind of, quote, cheat is just going to cheat themselves. They won't learn it, and then they'll fail the tests. So don't worry that that's going to inflate people's grades a lot. The people who are using it that way, they're just going to bomb the test on it. And it'll show up there, and that's worth 85% in the test category, right? Okay, so anyway, moral of the story, now on your Schoology quiz tonight, look through when you get it done and it's got this marked wrong, it'll put the right answer right next to it. And you can see if you were just typing it not in a way that Schoology could understand, or whether you really need to go and learn something. Now, judging by your response to this is whether or not I keep doing it this way. Okay? So, generally, do you like the idea? All right. And I'm going to hope that I don't see this. I'm going to hope that I hear about instances where people say, yeah, this one last night, I didn't know what was going on. Once I saw the answer, I totally could understand what I was doing wrong. If I hear that kind of thing, then that's going to tell me that this was a good idea. All right. And your homework for tonight is the completing the square where a is not equal to 1. That's saying that in this format, if this is a number like 2 or -1, when it's not just a 1, that's what makes it more complicated, and that's the kind we just learned how to do today. The kind where a is not equal to 1. Okay, that's all I got for you for